Alright, in this video we're going to look at how to use trig to find unknown angles of right triangles. Before we can begin that, we really need to think about what trig functions actually do, because that's going to help us make sense of this. Now, these are functions which you might recall from Algebra 1 means that there is a specific input and output. Now when you did functions in Algebra 1, you might have had something simple such as f of x equals 3x plus 5, wherein you put in a number and get out a number. Trig's a little bit more specific. What I put in to sine, cosine, or tangent, its input is specifically some type of angle, or rather its measure. What I get out, based on how we've been drawing these triangles and writing things out, is my output is a ratio. Now what we saw when we introduced the calculator is that most of these ratios are not very nice numbers, but they are still ratios. I'm getting two distinct things here. Again, I put in an angle and I get out a ratio. Well, not only is it the case that the sine of 52 degrees is always one particular value, but if I want some specific ratio, that is, if the sine of some angle were 0.4868, there is only one acute angle that will give that as its sine, or even as its cosine or tangent. So, this is going to bring me to the idea of trig inverses. An inverse undoes what was done, so this is going to allow us to go backwards. Rather than going from the angle to the ratio, I will go from a ratio back to the angle measure that I started with. Trig inverses, written with a little -1, and you can see, I'll bring the calculator over here. Here's sine, cos, tan. If you look above them, the second option is sine inverse, and cos inverse, and tan inverse. That's how these are read. They're read sine inverse, cos inverse, tan inverse. Sometimes they are called or written as arc sine or arc cosine or arc tangent, but I will generally refer to them using the sine inverse language. The original trig functions took an angle and sent it to a ratio. These have to go in the opposite order. So the input here will be a ratio, the output will be an angle. The reason we really need to understand this is so that you don't get confused on what you are doing. What am I going to use a trig inverse for? Well, one and only one thing. A trig inverse is used to find an angle. Keep that close, keep that in your mind, because you have to know this in order to be successful. If you don't use it to find an angle, you're going to run out of luck. Alright, let's take a look at how we actually use this. It's ultimately fairly simple, but do pay attention to how the work is written, because this is what's expected of you. This is what I want to see on your paper for full credit. Now again, always pay attention to whatever directions are there. Here you're asked to find each angle to the nearest tenth. So, I have given you a right triangle right here. This angle is marked as x degrees, and I can see that the hypotenuse is 18, and this leg right here is 7. So I'm going to begin this much the same way I have been doing for trig. I'm marking that this is the angle I am looking for. I know that 18 is the hypotenuse, and 7 is the adjacent leg. Well, again, I remind myself, write this down as many times as you need to when you're working with trig. SOHCAHTOA. TOA. What relates the adjacent and the hypotenuse? The answer is the cosine. So the cosine of this angle, what is this angle? Well, it's x degrees. The cosine of x degrees is 7 over 18. Now be careful here. Don't try and think about algebra or anything like that. What we are focusing on is we want to find this angle. And we know that if we are finding an angle, we use a trig inverse. So I have the cosine of x is 7 over 18. I will now invert this. If the cosine of x is 7 over 18, that means that x is the inverse cosine of 7/18. So we wrote this initial setup, and then we actually inverted it. X, then, the angle is the inverse cosine of the ratio. Again, the input is the ratio. What I get out is the angle. Now, I go to my calculator. I want the inverse cosine of 7 over 18. So, turn it on. I need to make sure I'm in the correct mode. So I go to mode, third line down, radian, I go over to degree and hit enter, quit, and I needed the inverse cosine of 7 over 18. So I will hit second cosine to get the inverse cosine. Be careful, make sure that you actually enter your keystrokes in correctly. And do 7 over 18. The inverse cosine of 7 over 18 is 67.11461952, accurate to, it looks like 8 decimal places. But I was only asked to go to the nearest tenth of a degree, which means x is about 67.1 degrees. Now be very careful when you're setting these up. The cosine of x is 7 over 18. That was the adjacent over the hypotenuse. If you're not careful when you're setting these up, your calculator might tell you there's an error. If you ever get an error, again, it probably means that you made a mistake in the setup. So again, the cosine of x in this triangle is adjacent over hypotenuse, 7 over 18, which means x is the inverse cosine of 7 over 18. I use the inverse trig functions whenever I am trying to find an angle. So x is approximately 67.1 degrees. Let's do one more example. It's not going to be very different. Here, I see a triangle. This time I'm given the two legs. I'm not given the hypotenuse. If I had a problem like this, I could find the hypotenuse, of course, using the Pythagorean theorem, but that's not what I'm being asked here. I'm just asked to find the angle. I'm asked to find x. So if I'm looking from x, again, I'll mark the angle. Here's the hypotenuse. I'm not going to use it. Here is the opposite leg. Here is the adjacent leg. If I need to relate the opposite and adjacent legs, well, SOHCAHTOA, you should have this committed to memory by now, tells us that the tangent is what I wish to use. The tangent of x degrees, the tangent of this angle, is 8 over 12. Now, I have my setup. Opposite over adjacent, 8 over 12. I could simplify this, but it's honestly not going to matter because my next step is going to be to rewrite this and then pick up a calculator. I want to find the angle, so I will use the trig inverse. X is equal to the inverse tangent of 8 over 12. Then I grab my calculator. If I had simplified 8 over 12, I would get the same answer that I'm about to get. Doesn't affect the answer. I will do the inverse tangent, so that's second tangent, 8 over 12. So this tells me that x is approximately, I have 33.69, so if I go to the nearest tenth, that is 33.7 degrees. Ultimately, that's all there is to using your calculator to find angles in a right triangle. You could do more, but again, this is all folding into the next level of trig. This basic skill, start with your setup, invert because you're finding an angle, and then pick up a calculator. There's nothing more to it.